Alright, we're talking about circle basics today. So let's look at the parts of the circle. This is called the center of the circle. In a circle is all of the points in a plane that are equidistant from a particular point. So every point on this circle is the exact same distance from that center point. And so since everything in that circle is based on that point, we use that point to name the circle. So the center is used to name the circle. That center point is used to name the circle. So the circle has an interior space and then it has an exterior space. So point I is an interior point. It's on the inside of the circle. And point E is an exterior point. It's on the outside of the circle. Okay, we were talking earlier about all the points on this circle being equidistant from that center point. The distance from a point on the circle to that center point is called the radius. Now the distance all the way across the circle through the center point is called the diameter. So if the distance from the center point to a point on the circle is called a radius, then a diameter is 2 times as long as the radius, or we can say the radius is half of the diameter. Alright, so those are the parts. Let's look down here, example 1. Point Q is the center of this circle. Round answers to the nearest tenth if necessary. First thing we want to do is name the circle. Remember, we name the circle based on its center point. In this case, it's Q. So we would call this circle Q. Now that's writing it out in words. You will also see it written like this. You'll see the circle symbol with the letter Q coming after it. So we would read this as circle Q. Okay, it says name all radii shown. Radii is just the plural form of radius. So from the center point to a point on the circle, right here, line segment QT is a radius. And then line segment QP is a radius. Basically, any point that's on the circle, you could draw a line segment from that point to the center point, and that would create a radius. What is the length of any radius in this circle? So right here, this radius has been labeled 16 meters. That means this would also be 16 meters. Anywhere I would come up with a point on the circle and draw that radius, it'd be the same distance, because remember, that's how a circle works. Every point on this circle is equidistant from that center point. So every radius will be 16 meters in this circle. So what would be the length of any diameter of the circle? Well, remember, a radius is half of the diameter. So if I want to know what the diameter is, I would double this. It would be 2 times 16. And so the diameter will be 32 meters. Alright, what is the circumference of circle Q? Well, you got 2 possible formulas you can use for circumference. 2 times pi times radius, or pi times diameter. So we just figured out that the diameter is 32, so I'm doing pi times 32, and the directions told us to round to the nearest tenth, so I can just type this in the calculator, and when I do pi times 32, we get 100.531 approximately. So when I round to the nearest tenth, I only want one number after the decimal. 3 is not big enough to round up, so it's going to be 100.5, and that will be meters for circumference. Remember that circumference is the distance around the circle. So this just told us how far it is around that circle, what the circumference is. Alright, what is the area of circle Q? Area of a circle is pi times radius squared. So we know that the radius is 16, so I would do pi times 16 squared. And again, just type it in the calculator. Pi times 16 squared. Get approximately this number. So when I go to round to the nearest tenth, 4 is not big enough to round up. So that 2 will stay like it is. Now, area is a two-dimensional measurement. It's how many little 1 by 1 squares will fit inside this figure. So because it's two-dimensional, the meters are squared. Whatever the units are will be squared. All right, name all of the interior points shown. So all the points on the inside of the figure here, all on the inside of the circle. Now point P and T are on the circle, so they are neither interior nor exterior. Inside the circle, we have these 3 points right here. Point R, point Q, and point S. Those points are interior, inside the circle. Exterior points, again, P and T are on the circle. They're not interior nor exterior. X is the only point on the exterior of this particular circle. All right, let's turn the page. All right, example 2, find the indicated measures, round to the nearest tenth if necessary. So remember, R stands for radius, so we want the diameter. So remember, diameter is twice as big as the radius, 2 times the radius. So we just do 27 times 2, and you get 54 inches. Circumference is pi times diameter. Since the diameter is 54, we're just doing pi times 54. And that gives me 169.646. So when I round to the nearest tenth, I'm keeping one number after the decimal. 4 is not big enough to round up. So 169.6 inches for circumference. And then area is pi r squared. And the radius is 27. So we're doing pi times 27 squared. It's a good size number. So rounding to the nearest tenth, 2 is not big enough to round up. 2,290.2 inches squared for area. Area is two-dimensional. The units will always be squared. All right, let's repeat that process over here. Now in this problem they gave us radius, and we had to find diameter. This time they gave us diameter, we need to find radius, so we're working backwards. So here where we multiplied by 2, here we're going to divide by 2, or multiply by half. So half a diameter, half of 18.6 is 9.3, so the radius is 9.3. For circumference, I don't know why I decided to use 2 times pi times radius this time, but let's just go ahead with it. The radius is 9.3, and I'm typing it all in the calculator. 2 times pi times 9.3, and rounding to the nearest tenth. 3 is not big enough to round up. Remember, for circumference you can use pi times diameter, or you can use 2 times pi times radius. They will give you the exact same thing. Again, because if I multiply the radius by 2, it's going to give me the same thing as diameter, so it all works out the same in the end. All right, area, pi r squared. Radius is 9.3. So let's type it in the calculator. Pi times 9.3 squared. Also, I am using the pi button on the calculator. I am not typing in 3.14. If you're typing in 3.14, there's a chance that your answer might not come out as accurate because you're using a rounded number. All right, centimeters squared for area. Area, again, units are always squared. All right, let's look at some new stuff. Everything up to this point should be stuff that you've heard before. Let's look at some new stuff. All right, this line right here is called a tangent. A tangent intersects a circle at exactly 1 point. A tangent intersects a circle at exactly 1 point. So notice how this line right here is intersecting the circle right here and nowhere else. A tangent intersects a circle at exactly 1 point. Now that point where it's intersecting the circle is called the point of tangency. The point of tangency. So that is the point where the tangent intersects the circle. The point of tangency is the point where the tangent intersects the circle. So a tangent intersects the circle at exactly one point, and that point is called the point of tangency. Alright, so this line intersects the circle at one point. Notice this line is intersecting the circle at 2 points. This is called a secant. A secant is a line that intersects a circle at 2 points. A secant is a line that intersects a circle at 2 points. Very important that a secant is a line. It has to be a line, so that means it has to continue on to infinity in both directions. It is a line. Because if you will notice, this right here is also intersecting a circle at 2 points, just like the secant did. But notice this is not a line, this is a line segment. It is not continuing on forever in both directions. This is called a chord. A chord is a segment that connects 2 points on a circle. So the 2 points on the circle, the 2 points on the circle are the end points for that segment. This is called a chord. Now within every secant, you will find a chord. If I got rid of the extra as it continues past these points, that would be a chord. So within every secant there is a chord. Within every line there are line segments. So the chord is the segment, the secant is the line. They both intersect the circle at 2 points. Alright, so let's look down here at example 3 and let's name each of the following. Let's name the center of the circle. So right here, point O is the center. Make sure you're just writing O. We're not naming the circle based on the point. We are just writing down the name of that point. So all you need is the capital letter. Alright, we're supposed to name all radii. Okay, well I see line segment ON is a radius. I see line segment OR is a radius. And I see line segment OM is a radius. Now here's something a little tricky. If it had said just to name all radii shown, then we would be done right there. Those are all of the radii that have been drawn into the picture already. However, it did not say to only name all the radii that are shown, it said name all radii. So, are there any other points on the circle where I could draw a radius? So right here, point T is on the circle. I could draw line segment OT, and that would be a radius. So that is a radius. It just wasn't drawn yet. It wasn't shown. Is there another point on the circle? Yes, point Q. I can draw line segment OQ. So these two right here are not shown, but they are still radii in that circle. Basically, however many points you have on the circle, that's how many radii. That's how many radii you will have, because you can always draw from the center point to any point on the circle to create a radius. Alright, let's name all the chords. Now remember, a chord is just a line segment with the two endpoints on the circle. So basically, any two combinations of points on the circle, and we should have a chord. So I see a chord right here, line segment MN. I see a chord right here, line segment MT. Now, as far as what is shown, those are the only two chords. However, we could draw a lot more chords in here. I could connect line segment Q in here. I could connect these 2 points, and that would be a chord. I could draw line segment QR. I could draw line segment QT. And I could draw line segment QM. I could draw line segment NR. Line segment NT. And we already got line segment QN and MN. Alright, over here, line segment RT. And line segment RM. And I believe that covers it. 1, 2, 3, 4. 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This way. Did I double O up? Nope. Okay. So, only these two were shown. These were not shown. But it doesn't matter. If they just ask for all the chords, you need to include the ones that are not shown but are possible. Just because something is not drawn yet does not mean that it does not exist. Alright, secants. Now, if you've already listed off all the chords, then naming all the secants is easy, because if I take any chord and just extend it, it becomes a secant. So basically, we take all of these and rewrite them, except where a chord is a segment, a secant is a line. So the only secant that's actually shown right now is line MT. Line segment MN is not currently a secant when you just look at it, but again, if we could extend it to infinity in both directions, that would be a secant as well. So basically, every single one of these chords, you change from a line segment to a line, and it becomes a secant. We're just putting arrows on the little symbol over the top to change it from a segment to a line. Alright, diameter. Diameter is the distance all the way across the circle through the center point. You can see that happening right here, line segment MN. I want to point out that a diameter is always a chord. The diameter always has its endpoints on the circle. The diameter is the longest possible chord in a circle. Alright, a tangent. Remember, a tangent intersects a circle at just one point. And you should see that happening right over here, this line. Line PS is a tangent. It's only intersecting the circle at one point, and that point that it's intersecting it at is point Q. And so point Q is the point of tangency. And that is it for circle basics.